Hi, my name is Kim Pallister, and I am a Chief Segment Gaming Architect here at Intel, working on game technologies and their impact on future silicon, which means I need to spend a lot of time looking forward to the adoption of these new technologies and think about what they mean. And I'm privileged enough to come and speak to you today about what we see in terms of the adoption of artificial intelligence in games, what it means in the near future and in the more distant future. So first off, I'm not an AI expert. I've been working in and around games for a couple of decades now, and I've seen a lot of new technologies get adopted. I think that what we're going to talk about today is looking at the ways in which different technologies get adopted, what affects that adoption. What are the factors that prevent developers from taking a new technology and incorporating it into their games? What are the challenges they have to overcome, even once some of the technical hurdles are still there? And then we'll use that to look at some of the future challenges around game development and around the gaming business, and see which ones we think AI shows some promise, and look at some early signs of where those technologies are already getting adopted in games today. Or in the game services and platforms around them. Now, games have always had some degree of AI, even from very early games, before some of the commercial examples that I'm showing here, even going back to the days of early computing in places like MIT, where you saw people, very early on doing things like chess and checkers and programming AI opponents to play. We've always had some degree of AI in games, right? And in some cases, those were very simple kind of patterns of behavior. And in other cases, they were pretty simple kind of state machines. There's a favorite example of mine here, a game called Mule from Ozark Software and published by Electronic Arts, that you could play for human players, or you could substitute any of the human players with an AI player and race against them to colonize a planet. And it had, in its time, what was a pretty sophisticated set of states, right? It had to do long-range planning. It had to participate in auctions against other players. Now, as we look at the way that AI has evolved over the past couple of decades, since some of those early titles, it's really evolved in a number of different ways. You've seen things like the kind of evolution of simple state machines grow to be somewhat complex. So where non-player characters or enemies would have different states in which they existed, and as they switch, as triggers cause them to switch between those states, when they went from kind of patrolling to afraid, or hunting after the player, or trying to engage in some kind of goal, they would then follow different behaviors that themselves broke down into different AI problems for things like pathfinding or 3D pathfinding in environments. How would enemies use elements for cover, or how would they scramble over obstacles in order to find the shortest path to their goal? And then we saw some of those become even more sophisticated as enemies enemies or non-player characters were programmed to work in squads and cooperate with one another, where one might lay down fire or keep an eye out for you while another one went around another angle to flush you out. And, this has been this kind of, and I gave a couple examples there of things like AI in, shooter games or 3D games. But the same kind of evolution went on in simulation games, in real-time strategy games. And, we've also seen that open up new kinds of gameplay, right? Where you had games that would attempt to kind of have more sophisticated motivations, right? A favorite example of mine, LA Noire, where the non-player characters would attempt to lie, and would exhibit certain behaviors when they were lying to the investigative detective. and maybe kind of avoid their gaze, and there would be certain tells that would an informed player could kind of clue in on, right? And we see lots of promise in near-term games of kind of taking that to even higher levels. But all of that is this evolution of, again, things like state machines and pathfinding routines, these kind of specialized AI that have really been tuned to a very sophisticated degree, but they've all been hand built. They're all built by the player to, all built by the designer to kind of get the AI character to behave in a way that they've anticipated ahead of time, right? And none of this represents what we hear about in current days when we talk about, when we hear all of the kind of news headlines around AI and things like machine learning and deep learning, right? And these are techniques where, people are not taking all of that AI that we've seen in the past couple of decades where someone has tried to anticipate what the function needs to do and what inputs it might run into, and then try and build a function to generate the necessary output. They've now flipped to this kind of world of generating things based on a large set of data, and where they're saying, I don't know what the function is, but I know that with these inputs and these outputs, I want some function that gets me from one to the other. And if I can train it based on that, then I will get some kind of a function that gives me a result, the right result, and now I can apply that to larger data sets. And it's a very different way of thinking about AI that at a very high level you could think of as the AI kind of leaving the hands of the programmer to some degree and saying, okay, I'm now going to help kind of coach this machine to develop a higher level function that I might not really understand, but I'm going to trust is going to give me the right result. And that's going to come in to be very relevant in a later part of the discussion here that we're going to cover. So in order to understand where that potential is, you have to think about it in the following way. You have a technology that shows a lot of promise, and I've kind of got a snapshot of a slide here that shows the many different kind of segments and market segments and different types of problems that we see people applying AI towards. And you have to think of, okay, what are the current kind of dynamics in the gaming business? What are the problems that people most want solved, right? And so in order to do that, you have to think a little bit about the way that the industry works and what the current and near future problems are that it's facing. And that's what I'm going to talk about next. So this is a very high-level slide, and I assume many people here play games and know something about them, and maybe a little bit about how they work, and a little bit about who the kind of big developers are and the more anticipated titles. But this is kind of a crash course on some dynamics in the industry that I think are going to become relevant in how we are seeing things play out. Right. So first off, gaming is a very big business. There are around 2.3 last data that I saw on this, about 2.3 billion people in the world that play games. Those 2.3 billion people spend about in one way or another, whether supporting games through ads or whether paying directly for games or buying items, they spend about 1.4 trillion dollars on media and entertainment, and about 10% of that is spent on games. So games themselves are a very big business, but more relevant is they're growing at a faster clip than the rest of a faster speed than the rest of media entertainment is. And so you have a very large market with a lot of investment going into it and a lot of competition, both within the games industry as people compete for kind of gamers' attention and dollars, but also outside in the broader media and entertainment context, right? When you go home in the evening and you decide whether you're going to spend time playing a game or watching a television show or something like that, that's where that kind of competition comes into play. And so amongst the people that are competing for those hours of attention from the consumers, or for their the dollars they're going to spend on that entertainment, there is a wide range of that content. You have everything from, and I just picked a couple examples here, but you have everything from kind of small indie titles like, you know, I've shown No Man's Sky here. It was a relatively small team and a couple of years to develop, but even titles like, you know, Among Us as being a, you know, pretty simplistic, but in terms of its like rendering sophistication, but catching on to a mechanic that has made it very popular. Certainly games like Minecraft in the past started as a very small team, but has become a huge hit, all the way up to these big kind of AAA blockbuster style games, where if you look at Red Dead Redemption 2, there are, just to pick that as one example, you know, 7 years of development. You know, last I checked, I think it was something like 2,500 people listed in the credits as having worked on that game in some capacity. So they're really massive undertakings, right? And they're getting, and at the upper end of those, they're getting very expensive to develop. And people think about a production of that size and then say, hey, I want to build this in a way that lets it do more. I want to let it develop it in a way that it covers more platforms, engages players for longer, raises the quality bar at the same time. It's a very daunting exercise. And so the investment risk level from the developers and publishers that are building these things are, you know, are an increasing factor that, you know, those people that hold the purse strings on those titles are worried about and thinking about how to address. And that'll become relevant later when we talk about this, right? Another thing that we see happening, not in the entirety of the games business, but in many parts of it, is that games in the past, where they might have been kind of thought about as like a boxed product, right? They were a thing you went to a store and you bought and either brought home on a disc or a cartridge for your home system, or maybe you went into an arcade and they were fixed in a machine there. They're transitioning in many cases to go from being kind of one-time packaged goods to being services that engage people over a period of time. And so that changes, you know, it seems like at first glance that would not change the game much. It might change the way in which you engage it. But ultimately, you know, if you're building a shooter like Fortnite, it's a, you know, it's a shooter and it's got all the same kind of mechanics involved. But the reality is that those kind of business influences do end up affecting the games. They end up affecting the dynamics of what the game needs to do to be successful. So an easy example is that as things transition to being services, the service, especially if it's based on a subscription or a regular kind of payment on the part of the user, they become more valuable if you engage with it more. This is why you see things like the Netflix video service showing up on many, many devices, is that you as a user will find that more valuable if you engage with it multiple times through your day or through your week. And we're seeing some of the same trends from these game titles, where the number of titles that are making themselves available across a wide range of platforms is increasing. So certainly the examples I've got down there, like Roblox and Fortnite and Minecraft, all show up across many, many devices. And that in turn affects how often people play them. And it also affects the kind of technology involved and the cost of developing them, because now the developer might be required to ship on multiple platforms, have multiple, you know, binaries and multiple SKUs for their product. So that cross-platform engagement is another factor that, you know, drives cost up, but also increases engagement, and is going to, you know, be a factor when we talk about the ways in which developers and publishers are hungry for AI to help solve some of their problems. Okay, I have a couple slides here where I'm going to talk about some of the areas that we see AI getting applied, and I haven't gone into all of them in much, you know, in a high level of detail. any one of these areas, if you typed in this, one of these bullet points, like analytics and AI in games into YouTube, you would probably come up with like an hour-long presentation being given at GDC that could go into it in more detail. I think that the interesting thing is that at a high level, we see some of the trends from the previous slide showing up as places that people are applying AI, right? So I'm going to give you kind of a survey of those to start with. So one example is, I talked about the increasing cost of these game titles. Well, that has been one of the first places that we've seen people trying to apply AI is on things like content creation, which is a huge expense here. So not necessarily saying, hey, go generate a game for me and I'll step back and see what pops out of the machine, but more how to use AI as a tool to help the content creators, the developers, right? Much in the same way that kind of animation tools helped animators not have to draw every frame of an animated film by hand. We see AI being a thing that can kind of augment the power of the content creator through, texture generation and, intelligent skinning of models, so you don't have to rig things by hand as much. Another area is on the kind of testing and deployment of these games, right? So we see lots of examples of developers using things both for kind of QA and test, right? How do I, let's say, deploy a large number of AI bots to go play test my game without having to pay, hundreds or thousands of users or play testing hours? You might still do that, but you might kind of do your kind of first smoke testing through some of these larger farms or kind of find corner cases there. And some of that testing can be done as part of the design as well. So we've seen examples of developers using AI for doing things like, facing off bots in death matches and then generating kind of heat maps of where the AI players are spending time on a map and figuring out whether it has kind of hot or cold zones and rebalancing in that way, right? Another area is on the kind of, as these games become services, improving the performance and cost and kind of the yield or economics of those services and of those communities through the use of AI, right? So as it becomes more important to kind of sift through your player behavior and understand where are they running into issues and kind of rage quitting the game, or where are they choosing to make a purchase or not choosing to make a purchase of an in-game item in a sale, and how do you kind of go through those reams of data and look for interesting trends? And that's an area that people are interested in applying AI. Similarly, part of how you improve the service is stop misbehavior of players on the service. Anti-cheat is one example. I've got a screenshot there of a presentation from Valve Software about how they took their anti-cheat system and augmented it with deep learning to develop a model where the basically an AI would look for behaviors from the games community that it could identify as cheats. And I think that there's a lesson there that the presenter talks about early in his presentation, which is they had humans that were reporting cheats, which meant that the humans were seeing something that we as humans are great, our brains are great pattern recognition machines, that if they were seeing something that struck them as strange, then a machine learning, deep learning algorithm should be able to do the same thing, right? And I think that's a little clue of kind of where some of these things can be applied. Another example that I've got down here is one that my team worked on, which is we see, again, another facet of the way in which games are kind of becoming integral to or integrated with services and communities is those people have to talk to one another. We see some people working on, machine translation, not just of text, but of real-time voice between players. So if I'm speaking English and other players speaking German or Mandarin, you could have a machine translation routine so that the two of them can communicate. And then the example that my team worked on is, which there's a screenshot of the proof of concept there, is applying machine learning and AI algorithms to anti-toxicity. So, one of the unfortunate things of game communities where people get really passionate about their games, but are also playing with individuals that they don't know, is that sometimes they treat each other pretty poorly. And that's it actually, we've done market research that proves that actually drives people out of gaming to some extent. And so we decided to see if we could do something about it. And it's an interesting example in that it actually uses AI for two components of the application. We did this in both with some Intel technology for doing speech-to-text conversion, and then we partnered with a company called Spirit AI, who does toxicity detection in text forums, in chat forums and message boards and things like this. And we merge those two together so that we can take a real-time audio stream, like in a voice chat, and then we use AI to do the speech-to-text conversion. And then there's a separate AI routine that does the kind of identification of different types of toxic speech and monitors that over a window of time so that we can do kind of both keyword detection of different kinds, but also watch a conversation over a period of time to see what the temperature of that conversation is, because you might have kind of a preference level that says, hey, the occasional bad word's okay, but if this sounds like a stream of abuse, I want to be able to flag it and then mute that audio. We do all that in kind of a very close to real-time method so that we can actually just dynamically mute a player so you don't have to hear them if they're being abusive. So that's an interesting example. Okay, another couple examples of things that we see coming to market and that start to, I think, give us some indication of some more interesting future areas for growth or for kind of future exploration. One is like just the runtime improvement and quality of and the trade-off between quality and performance and how we think about those being improved, right? So there's an example of that NVIDIA has been talking about lately of doing kind of upsampling of a rendered image and using a deep learning trained technique for getting a higher quality upsampling. And that can be used for increasing the visual quality. You could also view it as kind of getting the same visual quality for less graphics performance, which means you can apply more of that graphics performance to the realism of the objects that you're rendering. The net result is the same, which is you're using AI to kind of boost your quality level of games over time. One thing I didn't mention earlier, but I think is kind of an adjunct to games or an interesting kind of thing alongside games is that we see many usages today where, especially on the PC, which is kind of this, open and multitasking platform, where people are using voice or video alongside their games to augment the game's experience. And turns out that video and audio streams are both, video and audio are media types that loads of AI research has been done on. Right. And so there are a lot of applications that can be applied to those that aren't applied to the games themselves, but that can be applied to those audio and video streams for doing things like background removal, like we're doing here, or cleaning up voice streams, or things like the translation that I talked about earlier that can aren't touching the game themselves, but are going to affect the ways in which people share their game's experiences and more effectively participate in them. Right. There are some interesting research areas around things like game personalization and coaching. So whether that's kind of modification of your face in a video chat or of your voice in a voice chat, whether it's looking at your play pattern your play patterns over time, and feeding those into a routine that kind of could start to give you some personalized coaching or tips, right? Hey, from what we can see about the way you're playing, you should go do this kind of thing to improve your play style or technique, right? And then lastly, I've got a couple screenshot examples of what I think are very early examples of a domain that has huge potential going forward, which is one, I mentioned early on how things like, deep learning make use of these kind of large pools of data. And it's all happening kind of at the same time as, or in some cases because of, the advent of kind of cloud storage and cloud compute, and the fact that these large pools of data exist in different ways. And I think what we're going to see in the coming years is ways in which games at runtime tap into those areas within the cloud, and then can use that to kind of as almost like a distant cache to augment the game's experience, right? So the version of Microsoft Flight Sim that just shipped this year, which is a franchise near and dear to my heart and has been around forever, they have been talking about how they use the Bing Maps data and then apply some AI routines they've generated to actually infer what the geometry of different buildings is like from the imagery underneath, and then construct those kind of on the fly or as in a just-in-time basis. And so if a player is flying to a specific location that perhaps no other player has flown to before, and which their artist didn't think to go in and model the buildings by hand, they will attempt to generate those as actual geometry on the landscape. And they do a pretty good job of it. It's really interesting and worth checking out. So I think that that's kind of a little hint in the direction that we're going to see some games go, especially as they start looking at how to simulate really massive worlds and massive, million-person cities and things like this in future games, where it just won't be feasible to maintain all of that on the client. It'll have to be kind of a hybrid style approach, right? Similarly, the idea of tapping into capabilities in the cloud for kind of identification of stuff, whether that's from natural language processing and identifying things in speech, or whether it's computer vision and identifying objects. I think I've got a screenshot in here from Niantic. I think that what they're doing around a user with a smartphone in their hands has some capability to recognize things in front of it, but if they can tap into the cloud, they can make a lot more intelligent kind of inferences, not just about like what that object is, but maybe making guesses at where that user might be, which direction they're pointing, and then using that as part of a multiplayer simulation. So this idea of hybrid approaches, making use of cloud compute at runtime, I think has a lot of potential. So I wanted to talk in a few minutes that I've got left here to talk about what I think is a kind of hint at what some of the limitations in the ways in which technology get adopted. And so in order to do that, I'm going to look at a different example than AI, which is at looking at the kind of adoption of physics in games over time. Now, again, just like AI, games since very early on have had some kind of physics, right? You can go back to a title like Pong, or you can go back to, very early racing games and stuff where the physics wasn't really being kind of calculated according to Newtonian laws. Usually it was pretty simple, or the case in which it was being applied was being constrained, right? You maybe had real-time kind of calculation of some Newtonian physics with things like gravitar or asteroids, but on a 2D plane and with very kind of simple levels of collision, right? So early on in my my stint in the industry in kind of the late 90s, people started talking a lot about 3D games, right? Kind of synonymously with the rise of 3D GPUs, and how this, the advent of these 3D graphics in games and the kind of plentiful, or so it seemed at the time, floating point compute available on processors like those from Intel were going to mean you were going to be able to do kind of real-time physics, right? And I've got an example of a column in here from a friend of mine, Chris Hecker. I included a very old picture of him because it's a very old article where, he was talking about kind of doing, rigid body physics and doing things like simulating ponytails on characters and stuff. And soon after talking, doing a little bit of R&D there, he and lots of other folks in the space started talking not just about what it took to do the physics, but about what it would actually take to integrate it into a game. And they ran into kind of, you started to hear a lot of conversation about two main things. One being, how do I control it? I have this kind of system that gives interesting kind of emergent behaviors, but I want to make sure things don't go out of control or they end in a certain way. I don't know how to kind of control the physics. And secondly, what do I do if it kind of goes out of control? What do I do if it crashes? And most of us that spend some time playing these games remember these early cases, and you still see them in games today where kind of the something gets kind of stuck or trapped and the physics simulation goes nuts. Something starts to vibrate at or shimmy back and forth at a huge rate, and then the physics simulation explodes and either the game crashes or the thing flies off the horizon, right? And it really took a long wave of adoption of people making bets that adopting these technologies would, over time, the kind of more natural behavior or the emergent behavior they got out of it would be worth all of the work that they did to kind of wrangle and constrain these physics systems into behaving properly in games, right? And so you saw, titles, some titles taking very bold steps and kind of trying to do maybe too much physics or doing lots of it and it costing a lot. Half-Life 2 being a canonical example of both constraining the problems, but also kind of making a lot of breakthroughs in terms of physics-based puzzles and kind of unlocking areas by, balancing oil drums to move levers so that you could climb out of a region, et cetera. And we also saw some companies kind of either start physics middleware or tools companies or kind of incorporate that into their game engines as a thing that they would license to other people. And that really, it was not a short wave. It was kind of several decades before it kind of became a thing that developers were, and in particular the designers and artists, were just comfortable that that was a thing that, yes, there'll be real-time physics in the title. We know how to kind of watch for what might explode or blow up, how to constrain that, et cetera. And now it's, you can go into a title like Roblox where you're actually giving the end user the ability to kind of be the designer, and they can still, stack a mile-high pile of crates and do other things that in the past might have broken a physics simulation, but we've now become comfortable with trying to constrain them, right? And I don't mean that there are no more breakthroughs to make, but it certainly feels like there's some kind of an 80-20 rule where, many titles have got a pretty sophisticated and realistic looking set of physics. I've got a shot in there from Last of Us 2, which is a great example of them having spent some what looks like some significant time into kind of allowing the players to do things physically that previously would have broken a lot of games. So there's some great YouTube videos about someone taking kind of an extension cord and wrapping it around 20 things and then pulling it tight, and it still kind of works and slides things where you would expect them to, right? On this next slide, I have an example I wanted to make that that I think is, you know, pretty pertinent and kind of struck me recently. So if you haven't had the chance, you should definitely see if you can spend some time playing the Half-Life Alyx title. So I pointed to Half-Life 2 earlier as, you know, much earlier game in the franchise as being a breakthrough game in terms of this physics. I had a moment, and I wasn't the only one. This is someone else's screenshot, but lots of people have done this, where in a particularly hard part of a level, you know, with some hard enemies to overcome, I had a shortage of grenades, and there was a kind of place that you could kind of get ready access to grenades. So I actually went back to that place, and because the game's kind of character only lets you carry so many things, I grabbed a wooden crate and I filled it with grenades, and I said, okay, now I'm going to go get these guys, right? And picked up the crate and then kind of wandered into the region of enemies, you know, willy-nilly pulling grenades out and lobbing them out of my crate as needed. But I thought about this as I was prepping for this talk, and this idea that I can kind of take a large set of kind of arbitrarily shaped objects with, you know, you know, their bounding boxes aren't simple cubes, right? Throw a bunch of them into a crate, carry the crate with physical controllers that are themselves kind of being tracked in real space at a high frame rate to not break the VR simulation. And that I can do all of this without the physics simulation blowing up. And while the game's maintaining frame rates, I'm doing it in a fraction of a second, is really a testament to how far that's come. But it also shows us like just how far, you know, how many developments had to happen before that kind of thing could be done in physics, right? All of these kind of couple decades of kind of technology adoption and figuring out the corner cases and the tools and the testing and the different constraints and controllers were all necessary before we could get to that point. And I think we have a similar journey to go on as it pertains to AI. So this is my last slide, and I just want to kind of use that last point to kind of think about, okay, as you guys go on and maybe eventually work on AI technologies or on the application of those technologies in games, you know, where's that going to go, right? So across that list that I had earlier and in numerous other areas, AI offers a lot of potential to kind of lower the cost of development, lower the cost of operating game services, which isn't going to mean they're going to get cheaper. It's going to mean the same money is going to get poured in and the games are going to get bigger and better, right? Because they're all competing with one another. There are lots of other areas that AI could be applied, but they're in these areas where they impact game design, which means that all of these kind of, just like we saw with physics, these kind of peripheral problems of how do I direct the AI about what it is I'm trying to get? How do I manage it? How do I debug it? How do I feel confident that I can deploy a game on an end user's machine in the wild and that the AI doesn't do something completely nonsensical and break the experience for them, right? All of those technologies are as much and perhaps more of a hard problem than the AI itself, right? So just like these other frontiers, like, you know, several decades now of 3D graphics kind of growth and improvement in gaming, a couple decades of, you know, real-time 3D physics of different kinds, there is a huge opportunity for the next decade or two around the application of AI. And because it's kind of a ripe and new field, there is a huge opportunity to make a mark. There are loads of breakthroughs. It's not like some areas of graphics where we're kind of, you know, pursuing the last perfect pixel. Not that there aren't huge improvements to do there as well. But, you know, I know if I were a student today, it'd be a very exciting area to look at the future of games. With that note, I'd like to thank you for attending the talk, and I believe we're going to have some time for questions afterwards.
Hi, Kim. Thank you for choosing a topic and interesting presentation. Let's answer the questions from our viewers. Kim, in your opinion, what are 3 most important changes in the field of computer games brought by the introduction of artificial intelligence technologies? Thank you.
Sure. So the 3 most important areas, I think that one that I touched on earlier in the talk that will be probably one of the sooner implications is it has a potential to lower the cost of development and lower the cost of deploying games into the market. So doing QA on tests and testing on games, doing the content creation, and aiding artists to iterate faster. So that's going to mean that you will get bigger and kind of more fantastic games coming to market and being viable. So that's one. The second one is the use of machine learning in kind of large, very large data sets and contexts. So for things like games that I think of as having kind of one foot in the cloud and making use of cloud computing and AI on a large basis. So a good example, which I think I touched on earlier in the talk, is the latest Microsoft Flight Sim, where they are using some procedural methods to take geographic map data and generate models off of that, which is something you previously would have had to author by hand. And the third area, I think, is going to be around kind of how the computing device that you're playing the games on can more intelligently assist you. And so early examples that we see there are things like video production for streaming, using AI for background removal or for noise cancellation on your microphone. These are things that just make it a little bit easier to do the things around your games that you're doing. But I think we'll see things like, gaming systems that can kind of coach you on your play and realize how you might be doing better, or doing things like listening in on your voice stream and doing either language translation or toxicity detection and redaction, things like that.
Thank you, Kim, for answer. I have next question. What industries now require a particularly urgent implementation of virtual reality technologies?
So industries requiring an urgent level, I think I'll translate that as kind of which ones do we think we'll see it adopted in first? And urgent is kind of a matter of your judgment or whatever. So I think that for things like VR, and I'll kind of include AR in there, we saw adoption happening in kind of 2 ways. The first was areas where it was very helpful, but perhaps in the past very expensive. As the cost came down, it became usable by a wider segment of the market. So one example would be in things like construction and architecture. A decade ago, when it was much more expensive to do that, it may have only been feasible for, let's say, the architects of a very large industrial project, or maybe building a big hotel or casino, to envision the design and show their clients that kind of design. That's now something that a small scale builder or architect could do for an individual private home project or things like that, because you can do it on a regular PC. And so that area of technology that previously was only available to the kind of very, very high budget types of projects is now available in a wider sense. And then like all kind of technology adoption before it, entertainment and gaming is kind of always an area that if the technology is feasible and made at a reasonable price by some of these other markets, there'll usually be some corner of gaming that will adopt and make use of it just because people like to be more immersed and more entertained.
Thank you, Kim. Well, at the conference AWE 2 years ago, you talked about virtual assistant who takes on some of everyday tasks. Does it mean that in the future such simulation can completely replace reality? Thank you.
So I think that there's two things in there. I think the idea of completely replacing reality is like, there's obviously kind of science fiction pursuits, stories in science fiction where people kind of find an entertainment experience so entertaining and immersive that they choose to never come out or whatever. I think there's a number of reasons why that kind of thing won't happen. I do think that there has always been a portion of gaming where the level of the thing that the player is desiring is a very immersive and kind of realistic looking escapist type of experience, a very fantastic experience. And this is not just true for gaming and VR, even in cinema and movies, people kind of pursue having that very kind of high production value. And so within there, VR just gives another tool for the user to feel more immersed. And there's still many challenges before we can get to an area where people forget that they're inside it. Even I gave the latest Half-Life title as an example in my talk, and while the environments are very fantastical and kind of very realistic looking, I think we're miles away from somebody mistaking that for reality, right? So hopefully that answers the question.
Thank you, Kim. I have a next question. What are the main objectives in your product now? How is it going?
Sure. So most of my time is spent on kind of working on both the hardware and software technical requirements around future gaming PCs. And so I can't talk about products that haven't yet been released, but I can say that the a couple of areas as a whole that the industry is looking at. One is that we for some time now have been most of the kind of 3D rendering and real-time simulation has been focused on kind of getting this very high visual quality and high throughput, like high frame rate type of performance. And there's an emerging kind of area of technical focus now around making sure that you have very well-tuned and responsive systems, so very low latency inputs on the system, and very kind of systems that respond very quickly, even in the kind of single-digit milliseconds, because it can be shown that this affects player performance, right? Your ability to kind of target an enemy or respond to an action is somewhat dependent on how many milliseconds it takes your inputs to get through to the system and affect that simulation. So that's one area we're continually working with all of our kind of PC OEM partners to make sure that all gaming systems are doing well there. And then there are a few areas, like the example I gave earlier around kind of application of AI to kind of video and audio around your games experience, so that it's easier to stream, so that you can have a better visual quality. So those kinds of things are also an area of focus these days.
Very interesting, Kim. Really, your job is awesome. I have another question.
Yes.
What do you think? Are companies ready for implementation of virtual reality technologies now, or maybe they have to modify current processes and technologies?
Sure. So I'll restrict that to kind of talking about games companies in particular. I think that I'll give both kind of the yes and no side of that answer. I think that on the positive side, a lot has been done to take the existing production tools and game engines and rendering technologies and kind of adapt them to readiness for VR. So, people that have been developing in, the Unreal Engine from Epic or from Unity, or even using the kind of DirectX or OpenGL APIs on PC, those have all been adapted so they can be used for VR production. So you're not completely starting from scratch. I think that as people have done it over the past 4 or 5 years, there's been a lot of learnings about what works well, what doesn't work well, and that will continue. I think that some of the very kind of basics that people learned over the past couple of years about what allows someone to be comfortable in a VR experience for for an extended period of time, what modes of interaction don't work, what modes of kind of allowing people to move through an environment without experiencing motion sickness. Those basic rules we've learned, but there's still a lot of kind of trial and error and iteration that the industry has to do. So there's a lot of barriers there on that front, but still a lot of learning. And then the last thing is that the business has to be viable, right? If the size of the market is too small, then developers can't, choose to spend their time there and do quality experiences that get consumers to go, buy more systems in VR and buy that software. So we're at a level now. There's kind of it's been shown that small to medium-sized titles can ship either exclusively for VR or with VR support, and they can be profitable. So that's kind of started the ball rolling, but we're still kind of a long way away from dedicated, big budget AAA games that are exclusive to VR, but it'll come eventually.
Wow, Kim, so it's really very interesting. Thank you very much for your presentation, answers. Well, maybe next year we'll see you soon again. Thank you.
Oh, I'd be happy to. It was my pleasure. Thank you very much.
Thank you, Kim, so much. Друзья, позади насыщенная программа.
Colleagues, we have a very intense agenda behind. We've learned so many things. I hope that motivated more of you to learn more.